Okay. So microscopically, our kidneys are made up of these tiny, tiny structures called nephrons. And they are what does the filtering of our blood. They're the functional instructional units that make urine. And we have a lot of them, about 1 million per kidney. So we have about 2 million in our body. They have a tuft of capillaries called the glomerulus and a renal tubule, which begins as a cup-shaped glomerular capsule surrounding the glomerulus, those capillaries, and then it becomes the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule, and the collecting duct. So here we have that here. And for a lot of you, this is review. We've done some of this ad nauseum. So here's the glomerulus, is this tuft of capillaries in here, the glomerular capsule, the proximal convoluted tubule, the loop of Henle, distal convoluted tubule, and collecting duct. And this is a fairly simplified version of a nephron because it winds around quite a bit more than this picture shows you. Some terms. The renal corpuscle is the glomerulus and its glomerular capsule. So this whole thing, arterioles included, is the renal corpuscle. And the fenestrated glomerular endothelium is the walls of the glomerulus. The walls of those capillaries have holes in them, or fenestrations. Fenestrations basically mean windows. And those holes allow filtrate to pass from blood plasma into the glomerular capsule. And so our glomerular capsule has a couple layers. It's got a parietal layer, which is this outside part of the cup here. And then it's got a visceral layer, which is the inside part of the C that basically lines the glomerulus. The parietal layer is just simple squamous epithelium, the outside of that cup. The visceral layer are what are called podocytes, and these are branching epithelial cells. Podocyte means foot cell, and they have what are called foot processes, I guess because they look like toes. And these extensions of the cells terminate in these foot processes which cling to the basement membrane and form slits that allow filtrate to pass into the capsular space. So you can see some of the different cell types here. We've got in the parietal layer, we've got simple squamous, we've got these podocytes in the visceral layer of the glomerular capsule. In the proximal convoluted tubule, we've got these columnar cells with microvilli, and then the distal convoluted tubule, we've got columnar cells there as well. And in the loop of Henle here, we've got, especially in the thin segment, we've got more squamous type cells. So now that we've moved through the nephron, filtrate ends up at the collecting duct. And lots of collecting ducts eventually fuse together to deliver urine through papillae and into the minor calyces. Nephrons. When we looked at this in class with our labeling exercise, there are cortical nephrons and juxtamedullary nephrons. Cortical nephrons, most nephrons are cortical nephrons, and they exist mostly in the cortex of the kidney. They only descend a little bit down into the medulla. The juxtamedullary nephrons, there's fewer of those, but they have long loops of Henle that deeply invade the medulla. And they're really important in the production of concentrated urine. The medulla is very hyperosmotic. There's lots of solutes there, and so we can use that gradient to produce concentrated urine. More on that later. So here's a cortical nephron and some descriptions about a cortical nephron, and here's a juxtamedullary nephron. The juxtamedullary nephron also has this specialized peritubular capillary called the Vasa recta that descends deep into the medulla. So the way blood flows into the glomerulus is from the afferent arteriole, then to the glomerulus, and then to the efferent arteriole. The glomerulus is specialized for filtration. It's a high pressure system because those afferent arterioles are smaller in diameter than the efferent arterioles. And so you get a high pressure because of that. Then once you leave the efferent arteriole, you enter the peritubular capillaries, and these are low pressure porous capillaries that are adapted for absorbing things from interstitial fluid and from the renal tubules through the interstitial fluid. They cling very closely to the renal tubules in the cortex, and they eventually empty into venules. The Vasa recta is a specialized peritubular capillary. It arises from the efferent arterioles in the juxtamedullary nephrons, and these are long vessels that parallel the long loops of Henle. And these, like I said before, function in the formation of concentrated urine. And there's that picture. Another thing I want to point out to you is the juxtaglomerular apparatus. And the juxtaglomerular apparatus is a modified portion of the ascending limb of the loop of Henle that passes back by the glomerular capsule. And you only have one of these per nephron, but it's very important in the regulation of filtrate formation and regulating blood pressure. We have, so here's your afferent arteriole, your efferent arteriole, and this thing here is considered your juxtaglomerular apparatus. We've got macula densa cells that can, lost my pointer again, that can sense sodium chloride in the ascending limb of the loop of Henle. And then we've got granular cells, and these are the cells in the afferent arteriole, and these are cells that respond to blood pressure and secrete the hormone renin. So those granular cells are basically enlarged smooth muscle cells of the arteriole, and they have secretory granules that contain renin. They have pressure sensors, they have mechanical receptors that can sense blood pressure. The macula densa are these cells right here. They're tall, closely packed cells of the ascending limb, and they're chemoreceptors, and they can sense sodium chloride content of the filtrate. Okay, so our filtration membrane, which is over here in the glomerulus, consists of fenestrated endothelium, so capillary with holes, visceral membrane of the glomerular capsule, so those podocytes and their foot processes that make filtration slits, and then the basement membrane, the fused basal lamina of the endothelium and the visceral membrane. And this is what it looks like. And you can always refer back to these slides because they're posted on Moodle as well. So this filtration membrane allows passage of water and solutes smaller than most plasma proteins. So plasma proteins won't go through. And neither will blood cells. They just won't fit through here. A lot of large anions are repelled by this negatively charged basement membrane here. And that includes plasma proteins and other macromolecules, and so they won't get filtered either.